Okay, today we're going to be looking at direct variation in more detail. I've done a previous video already on direct variation, so I recommend watching that one first before you come and watch the second part. So we're going to continue off and do the last 2 dot points on the syllabus for direct variation, which are as follows. So the first one is to evaluate k, which if you recall is our gradient. In that equation, y equals kx, our direct variation equation. And it says, given one pair of values for the variables, and use the resulting formula to find the other values of the variables to solve problems in a variety of contexts. So basically what's that saying is that if you're given a point, say yx or xy, then you should be able to solve for k. And then if they give you another coordinate, but only one of those points, so say x or y, you should then be able to find the other one, either x or y, now that you've got k. So we're going to go through an example on how to do that. And then the second one is to graph and analyze the equations of that form. So not just graphing them, but actually working out what they mean. And use that to solve problems in a variety of contexts. Okay, so we'll go through a couple examples now. So to start off with the first one here, it says, the money earned by an employee is directly proportionate. So as soon as you see directly proportionate in a question, it's handy to write this down on the page so you know what you're working towards. So the money earned by an employee is directly proportionate to the number of hours that they work. Okay, so if they earn $120, they earn $120 if they work 8 hours. How many hours would they have to work to earn $200? Now, there's actually 2 parts to this problem. The first part is finding k, so finding your slope. And then the second part is now rewriting a new equation with 200 subbed in and then solving for the x. So we're going to go ahead and break that down. So we've got y equals kx. This is going to represent our cost. Our cost is directly proportionate to our amount of hours worked. Okay, and they've given us one pair of x and y, which is our 120 and 8. So we know that 120 is equal to k times 8. Okay, so we can solve for our gradient k, our slope. So k is simply going to be equal to 120 divided by 8, which is equal to 15. So now our new equation will be, our direct proportionate equation will be y is equal to 15x, or basically the cost that, the money we earn is directly proportionate to the amount of hours we work by a factor of 15, okay? So now it says how many hours would they have to work to earn $200? So now they've given us y, okay? And they're asking us to find what x is. So that's essentially the point that they've given us that lies on this line. So if we sub in 200 for y, and then get that is equal to 15 times x. X is simply equal to 200 divided by 15. And if you work that out, you get 13.33 recurring. Okay, so that's the amount of hours that they need to work, 13.33 hours. And if you convert that to hours, minutes, seconds, you'll get 13 hours and 20 minutes. Because 13.3 recurring is the same as 13 and a third, and 1/3 of an hour is 20 minutes. So you're going to get 13 hours and 20 minutes. That is the amount of time that they need to work in order to earn $200. So just recap, we did 2 steps there. We first found k. To rewrite our equation here fully, which was y equals 15x. And then they gave us a point and we had to find the x coordinate of that point, which we now can because we've got k. If we didn't find k, that wouldn't be possible. All right, next question. So it says a plan charges $2 per gigabyte. The cost C is directly proportionate. So again, y equals kx. Is directly proportionate to the data usage x, okay? So now instead of y and x, they're telling us to use c and x, but it really doesn't matter, it works the exact same. So our cost will be equal to k times the amount of data we use, x. So c equals kx, doesn't matter if we're using y's or c's. Okay, So now write an equation to represent this. So we know we've got C is equal to KX. Okay, so that's our general equation. But what is our equation going to be specific to this problem is what we need to ask ourselves. So they've actually already conveniently given us our slope value, our K, and the giveaway is that it's got this slash here, right, which means $2 divided by gigabytes, and that's what slope is, right? It's always rise over run. So you know that that's the K value, so that's going to be your slope. So your cost will be equal to 2x. That is it. There's nothing more to it than that. Your cost is directly proportionate to your data usage x, and it is by a factor of 2 there, which is what that K represents. So now let's sketch the relationship in part I. So C equals 2x. So we've got to draw up the Cartesian plane. But notice here how I'm only going to draw the first quadrant, because it doesn't make sense to draw the other quadrants, because cost can not be negative, nor can x, nor can your data usage be negative. The lowest that both cost and data usage can be is 0. So we're going to start there, right? And then it's just like sketching y equals 2x, but just in this first quadrant. So it's going to look something like that. All right, this is your cost axis, this is your x-axis, so we can write dollars there, and then we can write data usage. This is going to be in gigabytes. And that is it. That is simply a relationship, and that line will continue on to infinity. So it's nothing more to it than that. It's pretty basic. Part 3, interpret the relationship. So what does it mean? So what it means, when you're asking for what does the relationship mean, you're looking at the slope value, which is K. K equals 2, right? Which is $2 per gigabyte. So that means every extra gigabyte you use, right? So every extra gigabyte used, the cost increases by $2. That is essentially what that relationship is saying. So every time you increase, so every time you use 1 gig, right? Say this is 1, your cost is at $2. But now if I use another gig, 2, my cost now goes up by another $2, so it's 4. Now if I use 3 gigabytes, my cost goes up another $2, so I'm sitting at 6 now. So it just keeps working like that. So that's what the interpretation is. It's this relationship here. We're always talking about the slope when we mean interpretation, and that's how you interpret. Every extra gigabyte used, the cost increases by your gradient, which is $2, which is 2, yeah? So next, find the cost when 6 gigabytes of data are used. So now we've got our equation. Now we simply just want to find cost, so we want to find C, and they've given us X, which is 6. So this is the point they want us to find. They've given us the X coordinate, we just need to find the Y coordinate, or in this case, the C coordinate. So C is simply equal to 2 times 6, which is equal to 12. So the cost when 6 gigabytes of data is used is $12. And that's it. I hope this all makes sense, and I will make more videos based on the other topics, and I'll see you guys later. Thank you.